Hello and welcome to a Maths with Harry lesson. In this video we're going to have a look at solving binomial problems. On the screen here I have the general term for a binomial expansion, and we had a look at that in the previous video. So the binomial expansion is just a formula, if you like, to help you expand a bracket with two terms in it that is raised to a power, and the power has to be a natural number. A natural number is a positive integer, okay? So this is the expansion, and the general term is given by this here, where r is one less than the term number. So let me show you that in red here. We start off with the first term here, and we can see that r is 0 on the first term. So the first term, r is 0. On the second term, r is 1. So second term, r is 1. R is 1 less than the term number. Or you could think of the first term being the 0th term, but we don't really do that. We consider it as the first term. The third term along here, so 1, 2, 3, has r to be 2. There's our r, it's the bottom number in our combination, and it's raised to the power b. Our second term in the bracket is raised to the power r. So here on the third term, it's raised to the power 2. And that kind of carries on in our binomial expansion. Here's our general term again, and then this is our final term. So that's what the general term is. Remember from the previous video, this is a combination, okay? And let me write that in blue actually. NR written like that can also be written NCR, and that said N choose R. It's the number of ways of choosing R items from a total group of N items, okay? In the previous lesson we had a look at how can we choose 2 cards and how many ways is there to do that. How many ways is there to choose 2 cards from a pack of 52? Or how many ways is there to choose 2 cards from a hand of 7, okay? And the factorial notation for that is n factorial over r factorial rn minus r factorial. And we looked at what factorial was previously. So then this is the full expansion like I said, and just have a look under here. I want you to just note why I've highlighted these powers in green. And that is because the powers add to the power on the bracket. Whenever you do your expansion, the powers of A and the power on the B, the powers there must add to give you the power that is on the bracket. If it doesn't, then you've done your expansion wrong. So look here on the general term, if I add those 2 green powers together, I get this, and we'll do it in grey here, n minus r from the power on A plus r, the power on B. That gives me n, and n was the power on the bracket, okay? Let's highlight that in green as well. That's the power on the bracket there. So we know that that should be the case for every single term that we do. If we look at n minus 1, and then of course there's a power 1 there on the b, add those 2 powers together, we get n, and n was the power on the bracket, okay? If we look here, n minus 2 and 2, add those together, we get n, and of course n, of course, is the power on the bracket. So we know that when we have an a and a b on each of our terms, these a and b's, the powers on them must always add to the power on the bracket, okay? And just note as well, the r in the choose function here in our combination is the same, the r is the same as the power on the b, and that's always the case, r and r, okay? Now here, the first term, that is actually the same as writing this. Let's put a little arrow. That's the same as just writing this, a to the n, because we know that n choose 0 doesn't need to be there. How many ways are there of choosing 0 items from a total group of n items? Well, there's just one way, you just don't choose any of them, so that's 1. And then b to the 0, anything to the power 0 is 1, and so that's just a to the n. But I've shown you there on the first term, actually we still do have a combination involved there. Okay, so that's just a little background on the general term, the binomial expansion. And now let's do some solving of some problems. So, example 1, really when we're solving problems including binomial expansion and actual binomial terms and things, Really we're wanting to find like coefficients. We're wanting to maybe find, we've got, you know, a k in the bracket and we know a coefficient. We'll have a look at an example in a minute. And then we maybe want to find what the value of k is, okay? But for this example, we're just wanting to find a coefficient. So it says, find the coefficient. Remember, coefficient is just the number in front of the term. Find the coefficient of x to the 4 in the binomial expansion of this bracket here. 2 plus 3x to the power 10. Now, it's a binomial expansion. 1 because it says it, but 2 because we've got two terms. We've got 2 and then we've got a 3x. And we've got a power of 10, and 10 is a natural number. So we can do, we can use the binomial expansion for this. So, if we start off, maybe pause and have a go before I have a go and then press play. But I would start off maybe by just doing the expansion up to the x to the 4 term. You don't have to, you can maybe go straight to the x to the 4 term if you want, because you're not being asked to expand this, you're just being asked for the coefficient. So see what you can do with that first, and then press play and we'll work through the answer. What I'm going to do, like I just said, is expand up to the x to the 4 term, and then I'm just going to calculate the x to the 4 term to find the coefficient. So, let's do that. I always write down the bracket first, so 2 plus 3x to the 10, and then let's just do our expansion. It's going to be a to the n, so that's going to be 2 to the 10, plus, and then n choose r, so 10 choose 1, because this is the second term, so we have an r value of 1. 10 choose 1, 2 to the 9, we reduce the power of 2 by 1, and then the second term in the bracket comes in here, 3x, and we raise that to a power of 1. You don't really have to write the 1 there if you don't want to, but have a look. 9 plus 1 gives me that bracket power of 10, so that's good. Okay, this is the first term, so I'll write a 1 there. That's the second term. We are wanting x to the 4. So the second term has got a power of 1 on the x, so that's just going to give me an x to the 1. So if we continue with that, we want to basically get x to the 4. So the second term's not going to do it, it's going to be a power 1. The next term is going to be my combination, so 10 choose 2. Increase the r value by 1, so we get 10 choose 2, then we have 2 to the 8, we reduce that power, and then 3x squared. And again, we want these two powers to add to give me the power on the bracket. 8 plus 2 gives me 10. That's just a nice way of checking you're doing the expansion correctly. Then if we do the next one, that's going to be 10 choose 3. We will have 2 to the 7 and then 3x to the 3. Okay, that's the fourth term, but the fourth term is not going to give me an x to the 4 because we have an x cubed here. So we need to do the next term, which I will just write down. Where can I write it? If I rub these out, I suppose I can go under here. And I can add on 10 choose 4 will be my next combination coefficient, if you like. And then 2 to the 6, we reduce that power and increase the second power to a 4. And then I'm just going to write dot 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 because that continues, but I don't need any more terms because I'm only being asked to find the coefficient of x to the 4. Now, I said you could have expanded like that, or what you could really have done is gone straight to this term without doing any of these 4 terms above. Let me show you how you could have done that. So, we need the coefficient of x to the 4. So because we need an x to the 4, that means we kind of can work backwards. We're going to need 3x to be raised to the power of 4. This second term in the bracket involving the x needs to be raised to a power 4 so that we have a power 4. That's what we're needing, okay? So if we have that, what is going to be the power on the first term in the bracket? Well, the first term is a 2, and we know that the powers need to add to give me the power on the bracket. So working backwards, we know that we've got a 4 on the 3x to give me 3 to the 4, x to the 4 when we do that distribution. And then on the 2, it has to be a power 6 so that the powers add to give me the power on the bracket. So that has to be a power 6. And then we also need the combination. Well, it's a 10 because that's the power on the bracket, and we know that it's going to be a 4 because these numbers, the 4 there and the 4 on the second term, they always match. And that is really how you could have just gone straight to this term here without working along the binomial expansion. Either way is absolutely fine. If you can do this way, then maybe do it to save time, but don't save time and get it wrong, okay? Don't mess up these powers. It's safer to work along your expansion until you get to the term that you need to, but if you're asked for the x, I don't know, if it maybe has, find the coefficient of x to the 29 in some expansion, you're possibly not going to want to work all the way along until you get to the right term. You could just do the kind of thinking to get straight to the term. Okay, so hopefully that makes some sense. Right, anyway, this is the term that is going to give us x to the 4, so I'm just going to rub this out here. And then what we really want to do is just do the calculation on the coefficient. So 10 to the 4, 2 to the 6, 3 to the 4 is the coefficient. We don't need the x part because we're just being asked for the coefficient, and that's just the number in front of x to the 4. So that's my coefficient. Now if you put that into a calculator, let me see what you're going to get. In a calculator, you will get this, and it's a pretty big number. Let me have a look. Is it? It is 1 million. Let me write this down. 10 to the 4, 2 to the power 6. And in fact, let's put that 6 outside the bracket. 3 to the 4 is equal to 1,088,640. That is the coefficient of x to the 4 in the binomial expansion of 2 plus 3x to the 10. Hopefully that makes some sense. Don't worry about calculating these ones. You don't need to. You're not being asked to do the 4 first terms. You're just being asked to calculate the coefficient of the x to the 4 term, which is just the number. Do not give it with the x to the 4 part because that's not the coefficient. The coefficient is just the number in front, so we can kind of get rid of the x to the 4. Okay, let's have a look at the second example. This one is a little bit like what I mentioned a minute ago. Here we have an expansion, but we have a k inside the bracket. We know that g of x is equal to 1 plus k to the x, all to the power of 10, and we're told k is a constant. A constant is just a number that stays constant, okay? It says, given that the coefficient of x cubed in the binomial expansion of g of x, so the binomial expansion of this bracket here, the coefficient of x cubed is 15. Find the value of k. So maybe have a go at jumping straight to the term here, thinking about the powers, and then you can work out your combination part as well. But have a go, press pause, and then we'll work through the answer. I'm going to jump straight to the term that we need without doing the extra terms in front of it. So we need an x cubed because we want to work out the coefficients. I'll do it in grey, the coefficient of the x cubed. So I'm going to need a power 3 on the x term in the bracket. So working backwards, I'm going to need k to the x to be raised to the power 3. The reason for that, I'll just say it again, is because I need the coefficient of the x cubed term. So I'm trying to form the x cubed term here. This will give me a k to the 3 multiplied by an x to the 3 when we do the distribution of the power. And then that's going to give me the coefficient of the x cubed term. So that's the power of the second term in the bracket, this kx. So then I can work backwards and I can say the first term in the bracket, which is a 1, must be raised to a power of 7. And that's because I know the power on the bracket is a 10, and so I need these two, the 7 and the 3, the two powers on the two terms in the bracket, must add to the power on the bracket. Alright? So 7 plus 3 is 10. 10 take away 3 gives me the 7, so that must be the power on the 1. And then I just need my combination, so I've got the power on the bracket, which is a 10, and I need the x cubed, we've got a cubed, I need that 3 to match my combination, so 10 choose 3. Okay, and that will give me the coefficient of the x cubed. All I really want is just the number because I want the coefficient. So that is the x cubed term. So again, I need the coefficient, so let's just take the number. So the coefficient is just this bit here. The coefficient is 10, choose 3, multiplied by 1 to the 7, multiplied by k cubed. Now, I can do my my calculation on this, and I'm just checking what 10 choose 3 is. I think it's 120. Yes, it is. So that's going to give me 120 times 1 to the 7. We don't need that. That's just 1. And then we've got times k cubed. So it's 120 k cubed. That is the coefficient of the x cubed term. But I actually know what that is. We know that the coefficient is 15. So we've found the coefficient in terms of k, and we know that k is just a constant, but we need to find the value of k. So because I know the coefficient in terms of k, and I know what the coefficient actually is, I can set those equal to each other. So I can say, therefore, 120k cubed must be equal to 15. Okay, that's what we should get there. Then what I can do is I can basically work out the equation, okay? I can just find the value of k from this equation. I can divide both sides by 120 to give me k cubed is equal to 15 divided by 120. And then what I can do is I can just cube root that. Now, if you put that into your calculator, it will simplify it down to 1 over 8, and that's a little bit more simple. 1 over 8, cube root top and bottom, because we want to get rid of the k cubed, we just want k on its own. So k here will do the cube root of 1 over 8, which of course is a half. Therefore, k is equal to a half. And that is your final answer. That's what we needed to work out in this question. Okay, so really, it's just using the information that we know. Can you just pull out that term that we need? This is the calculation for the term. And then in a question like this, where we've got k's involved, calculate the coefficient. And because we know the actual value of the coefficient, set them equal to each other, do your, basically, equation solving to work out your k, and then that's all you need to do. Okay, I think this is the final example for this question. It is, and actually, it's quite similar to what we've just done. So I would pause and have a go. Here, you just have 2 coefficients that you need to find. So we've got a binomial expansion of 1 plus x to the 30. The coefficients of x to the 9 and x to the 10 are p and q. And then we want to find the value of p divided by q. So we're going to need to work out what p and q are, and then just do that final step of dividing them both. So pause and have a go, and then press play, and we'll work through the answer. You could have worked out p or q first, it doesn't really matter. I'll do p first. So p is the coefficient of x to the 9. Now, I'm going to jump straight here to just the term with x to the 9. The reason for that is because if I didn't, and I worked out, like in the first example, the terms before x to the 9, I would have the first term, I would then have x to the 1, x to the 2, x to the 3, x to the 4, etc., all the way up to x to the 8 to work out, which I don't really need to do. That's just a waste of time. So now we know how to jump straight to a term. I would encourage you to do that. So let's work out x to the 9 first. X to the 9 is going to be given by, well, we're going to need an x to the 9, so we're going to need the second term, x to the 9, like that. The first term has to have a power that when we add it to the power on the x, it gives me the power on the bracket. So we're going to have 1 to the, and let's think about this, 21, I think. That should be correct. Let me see, where's this question actually come from? I don't think I have the answer. No, I don't. Okay, so we'll take it that that is correct because we have x to the 9 to give me the x to the 9 part of the term. And then we need the power on the 1 to add to give me, when we add it to the x, to give me the 30. So 21 plus 9 gives me the 30. Then we also need the combination part. So we have the power on the bracket, which is 30. 30, choose 9, because it has to match, the bottom number has to match with the power on the x. Okay, so that's the term, but now all I need is just the coefficient. So the coefficient of that is just this part. It's just the number. It's the 30, choose 9, 1 to the 21. Okay, and then x to the 9, that gives me x to the 9. So all I need is that numerical part there. Now, I'm going to need my calculator for this. I'm going to need 30, choose 9. If you can't find the choose button on your calculator, Google the model of your calculator, and I'm sure it will come up. And it is a massive number. So, I'm just going to write it down. I think it's 14 million. Yes, it is. 14,307,150. That's the coefficient of x to the 9. So because that's the coefficient of x to the 9, that is p. Okay, because it tells us in the question, x to the 9 and x to the 10 have coefficients p and q respectively. So respectively just means they're in order. X to the 9 came first, so the coefficient is the one that comes first, which is p. And then the coefficient of x to the 10 is q. So let's do x to the 10 now. X to the 10, well, we're going to need an x to the 10 to give me the x to the 10 term. Then the power on the 1 is going to be 20, because those two powers have to add to give me the power on the bracket. And then what is my combination part? Well, it's going to be the power on the bracket, which is 30, and it has to match the power on the x, or on the second term, so that is a 10. Okay, so 30, choose 10. How many ways, basically, are there of choosing 10 items from a group of 30 items? And when we put that in, 30, choose 10, that is a massive number. And let me see, I think it's 30 million. So let me just take the coefficient of that. The coefficient is just the numerical part, which is 30, choose 10. 1 to the 20. I don't need that 1 to the 20. So 30 choose 10 is 30 million, I want to get this right, 45,015, I think. And then that, of course, is then Q. So that's the coefficient of x to the 9. That's the coefficient of x to the 10. That's not where we finished, though, because the question actually wasn't really asking for that. It was asking for p divided by q, but we had to work this out so that we can work out p divided by q. So we can just then say, and so, it's always nice to kind of put some grammar in your questions. P divided by q is equal to 30 million, sorry, no, it's not, it's equal to p first, 14,307,150. divided by 30,045,015. Now, let's type that into our calculator. 14,307,150 divided by 30,045,015. Let's double check that is correct. It is. That gives us 10 divided by 21. Now, I just want to check that is correct on the back of the book. So let's see, because when you have big questions like this and you're typing them into calculators, it can quite easily get a little bit wrong, because you can type the answer in incorrectly. Let me have a look. 8D, question 10. Let's have a look. 2.1. I think that's. Oh, hang on, q divided by p is what they wanted, I think. Q divided by p, it is. We did p divided by q, which was my question. So let me see what the other way round was. 1 divided by answer 2.1. So yes, that is correct. The question that I got it from wanted q divided by p, but I changed it to p divided by q. So that is your correct final answer.